Okay, so good morning. Today we're going to get started on solving two-step equations. So if we look in Schoology, that is what we have on the board for today, solving two-step equations, notes and practice. We'll do some Imagine Math Wednesday, multi-step problems on Thursday, Friday, cover some word problems, and that will have us ready for our very first quiz on next Tuesday. So Monday, we already did that. Tuesday, warm-up activity. First thing I want to do we have any questions from the Desmos work from yesterday I need to go over? Any questions from yesterday's work? Okay. Oh, you just got added in? Oh, you were just late to school, sorry. It is online, you can still make that up. So it's just in Monday's folder, so just get around to it when you get a chance this week. Any other questions on yesterday's work? Let's dig into today's work. So under major activities for today, do want to point out how everything is. So we have the work itself. It is due today, this evening. So please make sure you get that done. If you need a little more time than that, I still take it. I still give you your credit. It's fine, but the expectation is we should be finished it by tomorrow. So all it is a PDF of the worksheet. So complete the worksheet by showing your work for all problems. I know some of these are two-step problems, and you're like, they're pretty easy. Well, if it's easy to show your work, please take the extra 10 seconds to do so. So we have an understanding of how you got to that answer and make sure you really understand what to do when things get more complicated, as we'll see in multi-step problems on Thursday. You can submit your work using Kami. You can just try typing things up in a Word document. Or what I've seen many students find very easy is they just grab a sheet of notebook paper. They pull up the PDF. They just do the problems on here, pull out their phone, take a picture of it, and upload that picture to me. I've seen a lot of students having success with that. If that sounds easier than typing up the math, because I think some of you figured out typing math always isn't the easiest thing to do. You write it down better on paper and pencil. Go ahead, be my guest. Do it that way. Send me a picture of the paper. Just please make sure your name is clearly visible on it. That's it. So that is the worksheet. And then here's what we're going to have with our notes. Every time you will have a blank copy of the PDF notes, and most times you'll have the completed already posted before class starts. So I do have backup notes for you. Now, this isn't so you don't take notes. It's just so you have a nice digital backup copy. I still recommend, we're about to get into these notes so you can pull up the blank notes. If you had trouble seeing the board, if you want to look at the completed notes and follow along with them and use that as a guide to help you write your own, you're welcome to. So let's get started into our notes. Now, I fully recommend that we all get out some notebook paper. It's something to write this down with and actually take these notes. When you write stuff down, it engages more parts of your brain, helping you retain it better than if you're just sitting back and listening. So I'm going to give you a moment to get your notebooks out, all that great stuff. I know we're just getting started, just waking up, and we'll get into our notes. So we are solving two-step equations. You have done this? Yes. Yeah, I do have some extra paper up here. Yep. Yeah. So this is something we've covered before. You probably saw this back in 8th grade. You definitely saw this in IM1. If you took Algebra 1, again, you definitely saw this. So this isn't anything new. It's more refresher because I know some of you had a class last semester, a math class last semester. Some of you might have been last spring, some of you maybe even last fall. So this is just kind of being a quick refresher unit, like, hey, what are we doing here to solve to get variables by themselves? So we're just going to start with simple two-step equations. The first step is going to be undoing addition or subtraction. So if you notice with our do now today, I just said, hey, what, or actually, let me pull it up. I forget what the exact two questions were that I posed. It's like, oh, what's the opposite operation of this? What's the opposite operation of that? So just to get you thinking about this, thinking about inverse operations. So first, we are going to want to undo addition and subtraction, followed by undoing multiplication and division. For the majority of the problems, this will work, but there are a few problems where we do have to switch the order, and we'll look at those examples specifically. They're not very often you have to do that, but there are times we have to. So looking back at the do now, I had asked, what is the inverse operation of addition? You guys said subtraction. You are all correct. What is the inverse operation of division? You guys again correctly said multiplication, looking back to the do now. So this should be like, okay, I kind of remember this. Hopefully you do. So I'm going to give you a moment to make sure you got this copied down. Then we're just going to start getting into a few examples. I've got 4 examples lined up, including some problems where the order goes differently. And we'll talk about, hey, why are we doing the order different on this problem when we get to it? Yes, we're all good with that. Yep. Timer. So see a little bit of writing happening, not a big deal, giving you that time to get this down. Then, like I said, we got 4 examples to look at. They should go pretty fast. I think so. Yeah. You're welcome. So see a few people writing, no problem at all. We'll make sure you have the time to get it down. Um, you guys will see that I do record lessons. I have forgot to record this particular lesson first semester. I am recording it now. So please remember, if you're going to watch the recordings, all I'm doing is recording myself up here. I'm not taking the time to edit out these spaces where people are copying stuff down. So just keep in mind, if you're watching this later, you just might want to fast forward a little bit once we get these writing down spots. Thank you very much. I think we are ready for the first example. So the first example is a very deliberate first example here, because I know these ones get you just the slightest bit more. So we have the two sides to the equation. I want to get everything away from the letter A. So I have 6 is equal to A over 4 plus 2. What's the first thing I need to get rid of here? What's my first step here? Yeah, so how do I get rid of the plus 2? Go ahead. Yep, so I'm going to subtract 2 from both sides. And that will give me 4 is equal to A over 4. Now, A over 4, what operation is happening there? Division. So how do I undo division? Great, we multiply both sides by 4. So the 4 over here and the 4 in the denominator cancel. And then over here, it's just 4 times 4. That's 16 is equal to A. And that's my answer. Now, again, with solving, I'm not going to take the time to plug this in and check. These are 2 separate equations. Feel pretty confident. Yeah. I'll check. I think I am out of extra pencils, though. Let's hand my those extra one out. So while I'm looking for an extra pencil, yeah, no luck. Does anybody have an extra pencil? Thank you. If I were to plug 16 in here, if I did 16 divided by 4, that gets me to 4. 4 plus 2 is 6. So I can plug it in and check. So I'll give you a moment. I know some of you are still just writing down the very end of this. Give you a second to get this down. This is showing our work. This is the expectation I have for you. Yes. Yes. The expectation is we are showing our work just like this. I know typing it, sometimes you guys might find that to be a pain, but you can always write down paper and pencil and upload a picture to me. That works as well. Looks like we're ready for the next example. Oops, sorry. My bad, that was me. We'll get to the next example in a second. That one looks probably what you would feel like looks more traditional. There is a slight hiccup in it that I see some students run into, or maybe have a minor, like, wait, did I do something wrong type moment with it? But you won't be doing something wrong. It's just sometimes students, based on how it works out, will think they did something wrong. Now let's take a look at this one. So I have 9x minus 7 equals -7. So I had that 9 and that -7 on the same side of x. What do I want to do first here? Yeah, get rid of the subtraction. So we're going to add 7 to both sides. The 7's cancel out over here, leaving me with 9x equals, what's -7 plus 7? 0. Don't freak out here. That's okay. It equals 0. So what will we finally do here? How do I get rid of the 9? Be careful when it's right in front. It means they're being multiplied. So, yep, we divide it. So, x equals 0 divided by 9 is just 0. So, I will be honest, I do see some students freak out a little bit when they see x is equal to 0. It's not a very common answer we run into. Well, we solved something and just got that it's nothing. Some students freak out, think they did something wrong, but you actually did it all correctly. It makes sense. If I did 9 times 0, that's 0. 0 minus 7 is -7. So it does, again, check out. I'm going to give you a moment to make sure you got this one down. Then we'll move on to another example. Now, this example is one of the ones where we're going to go in a different order, and we'll talk about why we're going out of order for our steps in just a moment. Let's take a look at this one. So I have -1 equals 5 plus x over 6. Now this one's a little different because we have a giant fraction over here, right? So when we have a giant fraction, this is one of those ones we're going to take the steps in the reverse order because I can't really get the 5 outside of the top of this, right? I kind of need to take care of the 6 first. So if it's a fraction, what operation does that imply again? Division. Okay. It's division that's happening, but that implies we multiply, right? So I think that's, hearing both, I think that's what we were getting at, is one person just was thinking that next step ahead of what I was asking. So we're going to multiply both sides by 6. In doing so, the 6 in the denominator and the 6 on this side cancel out. -1 times 6, -6 is equal to the numerator, 5 plus x. Now that looks really easy to solve from there, right? What am I going to do to finish this up? How do I get rid of this 5? Good, there's no sign in front, so that means it's positive. So yeah, we're subtracting it. So subtract 5 from both sides, and we get -11 is equal to x. So I know I talked about like, oh, we'll first undo addition and subtraction, followed by undoing multiplication or division. This one goes in the reverse order because it's a giant fraction. So like I said, most of the time, we'll be following undo addition, subtraction, followed by undoing multiplication, division. But this is one of those cases we reverse it because it's a giant fraction. We need to take care of that fraction first. We've got one more example after this. And I'm just going to give you the rest of the class to work. You have both myself and Mr. Vaughn here to help and support you. And hopefully you're able to get this assignment in before the end of class. If you need more time than that, you do have tonight to finish it up for homework. I still see a little bit of writing happening. Go give you the time to get that down. Then we'll go on to the very last example. Okay. Here with this, I have parentheses. What do we typically do when we see parentheses? Does anybody remember? Yep, we're going to multiply. There we go. So a few hands on that for a few multiplies, or distribute is the fancier word for it. But when we distribute, all we're doing is multiplying. So let's go ahead and start with what you guys just suggested. 2 times n would be what? 2n plus 2 times 5 is equal to -2. Now that I look at this, this looks like all my other problems that we've done so far, right? It's just a 2-step problem. Well, what will I do first here or next here? Subtract 10 from both sides. And that gives me 2n is equal to -12. Final step here. Let's divide everything by 2. Perfect. And we get n is equal to -6. So again, if I wanted to plug that in, -6 plus 5 is -1. -1 times 2 is indeed -2. So those are our notes and examples on 2-step equations. Hopefully this was a great refresher for you. I know, again, some of you did have a math class last semester, so you should, if you were in that boat, you should be like, yeah, I remember this from last semester. Okay, I feel pretty good. If you did have math last semester, I know that it just might have been a little while, kind of, okay, knocking the cobwebs off, trying to remember what to do and get us ready for our next unit, which will start next week. So we got 2 steps today, Imagine Math on Wednesday, multi-step on Thursday, word problems on Friday, quiz review Monday, and then our quiz on this on Tuesday. So we're gonna spend just about a week on this and then get a quiz. Yep, go ahead. So. Yeah, the rest of class to work. I'm gonna stop sharing. I can stop the recording as well.